Well, hello and welcome to this exercise on real roots of a quadratic equation, an exercise suggested to me by a subscriber. And I think this is from a core one, A-level maths, and I think it's also suitable for anyone doing iGCSE. Now, it's not very clear, so I'm going to copy it out again. And it says, find the set of values. Again, the critical phrase here is the set of values, right? Find the set of values of k for which the equation x squared plus 2x plus 11 is equal to k into 2x minus 1 and has two distinct real roots. In other words, if we draw a graph for a given k value, the graph must cut the x-axis twice. Okay, so bear that in mind. Right, now moving on from that. So the next line will be this one here. Copy down the equation again. X squared plus 2x minus 11 is equal to k into 2x minus 1. Now, if we subtract k into 2x minus 1 from both sides, we end up with this here. When you open in the brackets, you should end up with that, because when you open in the brackets, you got 2kx minus k. And when that goes across, the sign will change. So minus 2, so minus 2kx, plus 2kx then becomes minus 2kx, and minus k then becomes plus k. I hope that's making sense there. Right. Now, the next step is to collect like terms. Now, we've got 2x and 2kx. So the coefficient of x are 2 and 2k, hence 2 and 2k there. The 11 plus k will be a constant, so that's a constant there. Okay. Now, the next step is this one here. We want to find values in order to have real distinct roots. B squared minus 4ac has got to be greater than 0. Now, b in this case is a coefficient of x, and a is a coefficient of x squared. Now, in this case, the coefficient of x squared is 1. So a is 1 in this case. And c is a constant value. 11 plus k is the constant value there. Okay, so now for our b squared, we end up with 2 into 2 minus k, because 2 into 2 minus k is a coefficient of x, and the constant value is 11 plus k, so we've got 4ac there. That's 4 times 1 times 11 plus k there. Right, so now we should try and expand the brackets. First, the 2 minus 2k all squared. That gives us 4 into 4k minus 4k squared. Now, if we expand this bracket now for the next line, if we expand that bracket, we end up with 4 minus 4k plus 4k squared minus 44 minus 4k is greater than 0. Now, you can see here that every term here has got a multiple of 4. So we can divide every term by 4. So now if you divide 4 by 4, you should get 1. Divide 12 by 4, you get 3. If you divide 4 by 4, you get 1k squared. If you divide 44 by 4, you get 11 there. Okay? So now don't forget here that 1 minus 11 will give us minus 10. So that will be the next thing. Okay, so now our equation then becomes k squared minus 3k minus 10. Now we need to factorize this value there. And we need two factors, we need two numbers, such that when you multiply, you get minus 10, and when you add, you get minus 3. And the two numbers that come into mind will be minus 5 and 2. Because minus 5 times 2 will give us minus 10, and minus 5 plus 2 will give us minus 3. So now our factors will then be k minus 5 and k plus 2. Now, we then find that k, right, say k is greater than 5. Now, this k greater than 5, I'll put a question mark there, is telling us that 5 is just a critical value, and so is minus 2. So 5 and minus 2 are just critical values. We want to use this to find out where the graph is above, where the graph crosses the x-axis, or if you like, where the x values are above the x-axis are positive. So what I've done is this one here. Now suppose k is 6, and we got this graph, and you see in this graph here that the graph crosses the x-axis at two distinct points, there and there, and all the y values above the x-axis are positive in this case. Now it's possible that the y values can be negative depending on the equation, right? So that's that one there. Now what if I try k is equal to minus 1? Now for k is equal to minus 1, we got this graph here. Now note that the graph does not cut the x-axis at any point at all, so there are no real roots. The x-axis is there, and this graph does not cut the x-axis at all. So it seems to me that anything between minus 2 and plus 5 will not be valid in this case. So let's try when k is minus 3. Okay, when k is minus 3, which is less than minus 2, we end up with this graph here. Now note that in this graph, the graph crosses the x-axis at two distinct points there. So the value of k we need for this equation to cut the x-axis at 2 points will be that k is greater than 5 and less than minus 2. K is greater than 5 and less than minus 2. And I hope all that made some sense, and please subscribe and watch my other videos. Thank you for watching, and bye bye now. Bye bye.